A water tank is cylindrical with a base radius of 45 centimetres. Water is pumped into this tank at a rate of 1 litre per second. What is the height of the water in the tank after 3 minutes? Well, first of all, we need to recognise that 1 litre is equivalent of 1,000, a volume of 1,000 centimetres cubed. So in 3 minutes, when 1 litre of water per second is being pumped in, it's basically 3 times 60 seconds equals 180 litres of water is pumped in in 3 minutes. So volume of water is 180 times 1,000. Leave it at that for a second. Now, what we need to do is basically calculate the area of the bottom of the cylinder, area of cylinder base, is pi r squared, and that's equal to 45 squared times pi, and I'm going to use 3.14 for pi, and that's going to equate to 6358.5 centimetres squared. So we know the volume of water is that centimetres cubed. So height of water will be that volume divided by the base of the cylinder, and that is equal to 28.3 centimetres, and that's your answer. Now on to the second part of the question, which in itself is in 2 parts. It says, a large container when full holds 24 litres of water, measured correct to the nearest litre. Write down the least possible value and the greatest possible value in litres of the amount of water in a full container. Now this is a question about rounding. So it says it holds 24 litres of water measured correct to the nearest litre. So the least value could be, considering normal rounding, the least it could be is 23.5 litres, because you've got a 5 there. That rounds up to the next litre, so it rounds up to 24 litres, which is what we've got there. Now the greatest value, as far as I'm concerned, is 24.4999 recurring. Okay. So you'll be assessed on the quality of your written communication in this part of the question. The tank has a capacity of 320 litres, so we're talking about another tank now, measured correct to the nearest 10 litres. So again, they're talking about nearest, so they're talking about rounding once again. Explain showing all your calculations why it is not always possible to empty 13 of the large containers full of water into the tank without the tank overflowing. I think the question's badly worded, really. But anyway, what they're getting at is that what you got to see is that the situation, this situation will occur for the smallest possible size of tank, which is, it's correct to the nearest 10 litres. So the least size capacity would be 315 litres. I hope you can see that. If it was 314, it would be rounded down to 310 litres. At 315 litres, it's rounded up to 320 litres. So dividing say 13 of the large containers, dividing 315 litres by number of large containers is 315 divided by 13 is equal to, that's litres, equal to 24.23 litres. .23 litres is smaller than the maximum size of large container. And so will not always be possible to stop the tank overflowing. You could have done this a different way. You could have said basically that you've got the size of your tank, which is 315 litres, the smallest size possible, and you could have divided that by the maximum size of container, which, as I said, is 24.4999 recurring. That's a bit awkward, but you could have said in your answer that rounding approximately to 24.5, could have seen that that gives, I'm sorry, I should put litres there, 12.86 large containers. So that shows that in certain circumstances you can't actually get 13 of the large containers into the tank.